Hey everyone, in this video we're going to talk about measurement validity and measurement reliability. If you haven't watched the previous video on operationalization, I recommend you go back and watch that video first, because this video is going to pick up right where that video left off for the discussion of some of the measures that we talked about at the end of that video. But before we jump in, measurement validity really refers to the degree that our observable indicator, or if we are quantifying, our quantifiable measure, actually reflects the abstract concept or the defined concept that we're really trying to capture. So once again, validity is really about accuracy. To what degree does our measure really capture the thing that we're trying to actually measure? Measurement reliability refers to the degree that our instrument, our observable indicator that we're using, produces consistent results of the phenomenon, that is, of the concept, over repeated measures. Now, both of those topics sound a little bit abstract, so the easiest way to conceptualize of measurement validity and reliability is through the use of a thermometer. So if our defined concept, the thing that we're actually trying to measure, is the internal temperature of a person, we would want our thermometer, that is our instrument, to have measurement validity and measurement reliability. And once again, measurement validity refers to the degree that the instrument actually captures or measures the concept that we care about. So in this case, if we're talking about measurement validity or accuracy, we're dealing with the degree that the thermometer actually measures the real temperature of the person that we are trying to evaluate. Reliability refers to the degree that thermometer produces consistent results over multiple uses. So if the internal temperature of our individual is, let's say, 98.7, a valid thermometer, an accurate thermometer, would read a temperature of 98.7. A reliable thermometer would produce a result of 98.7 on the first read, on the second read, on the third read, and on the fourth read. An invalid thermometer, or an inaccurate thermometer, would perhaps produce a temperature of 101.2, maybe 103.4. It would not actually capture or measure the internal temperature of the subject we're trying to evaluate. An unreliable thermometer, on the other hand, would produce varied results. So we might get, for a person who actually is at, let's say, 98.7, maybe a reading that says 96.2, maybe another reading that says 102.1, maybe another reading that says 98.6, and yet another reading that says 100.0. So in both cases, we wouldn't want to use those thermometers that are producing results that are off of the true temperature, or producing a result that is varied around the true temperature, because neither one will be particularly beneficial for decision making. Alright, so let's go back and look at our example from operationalization. We looked at different ways we could operationalize college readiness. One popular metric is the SAT exam, which defines college preparedness as a score from 400 points to 1,600 points. The SATs are designed or defined as a student's mathematical plus their reading plus their writing ability. This is assessed through a standardized test that uses a series of multiple choice questions, which are then scored in a particular way to create that 400 to 1,600 metric. The big question we might ask with the SAT scores is whether or not this test, these set of standardized questions, really captures a student's level of college preparedness. So the question of validity is whether or not our metric, our quantified measure in this case, actually tells us about the concept of college readiness. There are a lot of different ways to talk about validity, but I'll only mention three here. The first is face validity. Face validity generally refers to the idea that most people would believe that your indicator is a good measure of the concept. Although the SAT scores are widely used, I don't think most people would agree that a standardized exam would be the best metric of a student's college readiness, because college readiness often includes other components like study habits and motivation. A second type of validity is what we call content validity. Content validity refers to the extent that our measure covers or addresses the construct of interest. So in this case, we define as our concept that a student's college readiness is about their math ability, their reading ability, and their writing ability. So our question here for the SATs for a content valid discussion would be whether or not the questions on the exam are really doing a good job at tapping into or assessing students' math, writing, and reading ability. And in this case, I think most people would agree that the SAT scores do a pretty good job of assessing mathematical, writing, and reading ability. So we'd say that the SAT scores have content validity, or they are content valid. The third and final one I'll talk about is what we call criterion validity, which refers to the extent that our measure correlates with other measures known as criteria that also tell us about the concept. So in this particular case, we might think that SAT scores, if they are indeed a good measure of a student's college preparedness, will be correlated with measures like high school GPA. Since high school GPA occurs simultaneously with SAT scores, we might call the congruence between those concurrent validity, meaning that the SAT scores and high school GPA agree, that is, they are correlated to a high degree, and tell us about a student's college readiness. Perhaps the best indicator or the best metric of college preparedness is how well a student performs in his or her first semester of college. So we might say then that SAT scores are a really good indicator of college preparedness if they are correlated well with first semester college GPA. If they are, we would call this predictive validity, which would be a special case of criterion validity, since these measures all tell us about a student's level of college readiness. In addition to measurement accuracy or measurement validity, researchers should also be mindful of measurement reliability. Once again, reliability refers to the consistency of a measure, or to the degree that the measure or indicator produces consistent or similar results across repeated use. In general, we talk about three types of reliability: over time reliability, or what we might call test-retest reliability; across item reliability, or what we might call internal consistency; and across individuals or across subjects, which we might call intercoder or inter-rater reliability. The question of test-retest reliability on the SATs is whether or not if a student takes the exam more than once, will he or she get roughly the same score. There have been a lot of examinations of this question, and in general, the SATs are a reliable indicator, meaning that students that take the exam more than once tend to get the same score. The standard error of measurement, a concept we'll talk about later in the lecture series, is approximately 32 points. This means that on average, if a student takes the test a second time, there's a 68% chance that he or she will score within a range of 32 points above or below the first score. So that means that scores aren't drastically different when students take the exam again. So the exam has test-retest reliability. The second question is one of internal consistency. This really refers to the degree that the questions match each other. That is, do the mathematic questions all produce similar results? So if a student has a high level of mathematical ability, he or she should get all the questions right. Similarly, if a student has low mathematic ability, he or she should get most of the questions wrong. So once again, the SATs have a general high level of internal consistency, meaning that the set of questions used really do a good job of capturing those core abilities or core academic skills. Finally, we may ask whether a measure has a high degree of intercoder reliability, which really refers to this idea that if we have different people assessing the exam or assessing student performance, will they produce similar results? For the SATs, this is not really a big issue. Since the SATs use multiple choice questions, basically they're machine coded, so the machines will produce consistent results across all student grading. However, you can imagine that if there were human coders, human graders, who are reading, let's say, essay questions, which there is a essay option or writing composition part, to what degree do two different teachers or two different instructors read the same student essay and come up with the same score? So, for instance, if one teacher read an essay and scored the essay a 1, another teacher read the essay, scored the essay a 5, and another teacher read the essay and scored it a 3, then we would have big questions about intercoder reliability, since the people who are coding the data or assessing the essay are coming up with different results. Once again, with the SATs, for most of the 1600 points, is not really an issue because those are multiple choice questions that are scored by machines, which are by default highly reliable when it comes to the way they score or code the results.